you've got BaOH2. So you should recognize that. It's on page 333. You should recognize that as a base. How do I recognize it as a base? Well, it has a metal combined with OH minus. And you're adding HF, which is not on your list of strong acids. It's not a strong acid. It is a weak acid. But like it's similar to the strong acids, a lot of the strong acids are a hydrogen joined with one of these halogens, right? HCl, HBr, HI, those are all strong acids. Because the halogens are good at attracting electrons, and they're usually relatively stable if they pull the electrons away from a hydrogen. So HF, it's not as strong as the other ones, because the fluorine is a smaller atom. When it takes an extra negative, it creates more of a charge imbalance. But it can still do that to an extent. So I would still recognize this as an acid. And anyway, if this is a base, it's a decent chance that what I'm adding it to is an acid, because they always react together one with the other. So as an acid, I also know an acid has to have an H plus or a hydrogen attached to a relatively electronegative atom, right? Because that electronegative atom is going to pull the electrons away from the hydrogen. If you leave the hydrogen without electrons, it's very susceptible to having a different pair of electrons come in and start sharing with it. So what I expect to see is my base picking up the H plus, my acid losing the H plus and being left over without it, and then this Ba is just there as a spectator because it already has a +2 charge to begin with. It already has a noble gas configuration. It's not going to undergo any change other than just being in solution with the +2 charge. But then I've got to make sure everything's balanced. So I've got 3 hydrogens on the left and only 2 on the right. So I need more here. I will then need more hydrogens to keep 4 on both sides, and I will need more of these to keep 2 fluorides on both sides. Now it's balanced. So with acid-base reactions, I will give you at least one of the 2 substances will either be recognizable as a base because it will have an OH minus, or it will be one of the strong acids on the formula sheet, or it will be an acid of the carboxylic acid type that we talked about, where you have this general structure. You recognize this is a carboxylic acid based on the atoms that are present and the way they're grouped together. That is able to donate an H+. So if you see that, then you also know that's going to act as an acid and donate an H+ to whatever other molecule was present that could possibly use a lone pair to accept that H+ and share with it.